Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Cbse board exam, we'll be dealing with the sample paper published by Cbse for the year 2021. Cbse has changed exam patterns for the year 2021, and the mathematics paper has undergone some radical changes. So therefore, this video is devoted to explaining a part of the sample paper for mathematics. This is the 8th video of the same, and today we're dealing with a part of section 4. Section 4 contains 3 marks and 3 marks per question, and we will also have internal choices in that section. So now let's move on to the first question. The first question is: prove that the greatest integer function defined by f(x) equals x inside square brackets such that 0 is less than x less than 2 is not differentiable at x equals 1. So now let's look at our function that we're going to have to prove. So the function here is f(x) equals to the greatest integer function of x such that 0 is less than x less than 2. And we need to be able to prove that this function is not differentiable at x equals 1. So the key word is not. Now, the condition for f(x) to be differentiable at x equals 1 is for f of x to be differentiable at x equals 1. You need to be able to prove that limit x tends to 1 minus f of x equals limit x tends to 1 plus f of x is equal to f of 1. So basically, the left limit must be equal to the right limit so that a function is existing and it's differentiable, and this should be equal to f of 1 in order to make sure that it's differentiable at x equals 1. So let's look at our function. The function is f of x equals the greatest integer function of x. So for the value x equals 1, f of 1 will be equal to the greatest integer function of 1. So the greatest integer function of 1 will be equal to itself. So 1. So f of 1 is equal to 1. Now let's look at the left hand limit, or LHL. So that is limit x tends to 1 minus f of x, which will be equal to limit x tends to 1 minus the greatest integer function of x, and I say that this value is equal to 0. Why? Because x tends to 1 minus represents the fact that the value of x approaches 1. So basically, the value of x is now less than 1. And for the greatest integer function, whether the value be 0.9 or 0.999, the greatest integer function's value is still the same, 0. So therefore, the value of the left-hand limit is equal to 0. Now this step will offer you 1 mark. So this is the marks distribution for that. If you look at the right-hand limit, that is the RHL, it'll be limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus greatest integer function of x, and that will be equal to, this case, is 1. So how did I know that the value here is 1? Because the function is defined in such a way that 0 is less than x is less than 2. So therefore, the function that is x, so the function that is greatest integer function of x will be operable in the values where x is less than 0 and greater than 2. It's only between these two numbers that x is existing. So that means we have open interval 0 to 2. So if you see that 0 is less than x less than 2, then you know that the open interval 0 to 2 is the interval in the question. So that means that whatever value of x is present which is greater than 1, it will be in between 1 and 2. It cannot be greater than 2 at all. So any value, like for example, you have 1.1, the greatest integer function will be equal to 1. 1.58, the greatest integer function is still equal to 1. 1.999999, the greatest integer function of that would still be 1. So therefore, the value of the right-hand limit is equal to 1. So you get another mark by writing all of these steps. So as you can see, the left-hand limit, or the LHL, is not equal to the right-hand limit, the RHL. So therefore, f of x is not differentiable at x equals 1. So LHL is not equal to the RHL, and the LHL is not equal to f of a. So therefore, fx is not differentiable at x equals 1, hence proved. Now let's look at our next question. Now this question isn't actually the next question. It's basically the OR question that is present for question number 31. So question number 31 has an internal choice. You can either do the above or this question that we're going to do. So in this question, x is given as a sec theta, y is given as b tan theta. Find d square y by dx square at x equals pi by 6. So how do we solve this question? Here, x equals a sec theta. So now what we do is we differentiate with respect to x. No, we can't differentiate it with respect to x. That is a mistake from my end, so that is incorrect. What we have to do is we have to differentiate with respect to theta, because the right-hand side is a function of theta. So therefore, we have to differentiate with respect to theta. So that means dx divided by d theta is equal to a times d by d theta of sec theta, which is equal to a times sec theta times tan theta. Okay, now let's consider this as equation 1, and we'll also write d theta by dx is equal to 1 by a sec theta tan theta. I'll get back to that as we go along. Now let's move on towards y. Y is given as b times tan theta. So now we have to differentiate with respect to theta. So you will get dy by d theta is equal to b times d by d theta of tan theta. So that is equal to b times sec squared theta. This is equation number 2. Now, our question is to find out the second derivative of y with respect to x. So what we're going to do first is to find the first derivative. So we will be finding dy by dx. But how do we calculate dy by dx? That is where we use the parametric form of differentiation. You know the value of dx by d theta and dy by d theta. All you have to do is simply write dy by d theta divided by dx by d theta. So in normal parlance, d theta gets cancelled, so basically the left-hand side is equal to the right-hand side. So now let's put in the values from equation 2 and equation 1. So dy by d theta, the value is b sec square theta divided by equation 1 is a sec theta tan theta. Now, what we are going to do is we are going to eliminate sec theta from both the numerator and the denominator. So that means it'll be b by a times sec theta divided by tan theta. So that means you'll have b by a times 1 by cos theta into cos theta by sine theta, because it's 1 by tan theta. So that means since tan theta is sine theta by cos theta, then 1 by tan theta will be equal to cos theta by sine theta. The cos values are cancelled. 1 by sine theta is equal to cosecant theta. So therefore you will have b by a times cosecant theta as the value of the first derivative of x. First derivative of y with respect to x. Now we will differentiating with respect to x on both sides. So now we have d squared y by dx squared on the left hand side. This is the second derivative. The right hand side will be d by dx of the first derivative, that is b by a times cosecant of theta. So now you face a dilemma. You see that we have to differentiate with respect to x, but all we have is a function in theta. So how do you differentiate? Well, there is no problem. You can simply differentiate with theta and then write d theta by dx in the end. So what we'll do is d squared y by dx squared. That will be equal to b by a times the differential of cosecant theta with respect to theta. That is minus cosecant theta times cot theta, and then you will write d theta by dx. But if you notice, we wrote d theta by dx as 1 by a times sec theta times tan theta. So this is the moment where we have to plug in that value. So therefore the right hand side will now be b by a minus b by a times cosecant theta times cot theta times 1 by a sec theta times tan theta. So now what are we going to do? Let's take a to this side. So it's basically the same denominator. So we will multiply a together. So you get minus b by a squared. Then you already have a cot theta and you already have a cosecant theta. Then you have a cos theta, and then 1 by tan will be cot theta again. So now what we get is minus b by a squared times cot square theta into cos theta, and cosecant theta can be written as 1 by sine theta. So cos theta by sine theta, which again gives you cot theta. So therefore the final answer, that is d squared y by dx squared, is equal to minus b by a squared times cot cube theta. So this is the final equation that we get. But are we done? No, because we need to find the value of the second differential at x equals pi by 6. So let's plug in the value. So d squared y by dx squared at x equals, actually it's at theta equals, because the right hand side is still in the form of theta. So at theta equals pi by 6. So it will be minus b by a squared times cot cube, or instead of cot cube we can just write cot pi by 6 the whole cube. So that is equal to minus b by a squared times cot pi by 6 is root 3. So now what we're going to do is root 3 the whole cube. So that means root 3 the whole square times root 3. So that is 3 root 3. So therefore, the final answer is minus 3 root 3b divided by a square. So that is your final answer. The value of d squared y by dx squared at theta equals pi by 6. Now, the marks distribution for this question is a bit significant. So for finding dy by dx as b by a cosecant theta, you get 1.5 marks. To find that d squared y by dx squared is to be equal to minus b by a squared cot cube theta, you get 1 mark. And for the final answer, you get 0.5 marks. Now let's look at the final question for this episode. This is question number 32. In question number 32, we have to find the intervals in which the function f given by fx equals tan x minus 4x such that x belongs to 0 to pi by 2 is a strictly increasing, b strictly decreasing. We need to find those two intervals. So the given function is fx equals tan x minus 4x. What are we going to do now? The first step is to differentiate with respect to x, because over here now we're going to differentiate, then we're going to find the intervals. So first step is to differentiate. d by dx of f of x can be written in symbol as f dash x. That will be equal to the differential of tan x, that is secant square x, minus 4 times the differential of x, which is 1, so minus 4. So writing this step will give you 0.5 marks. Now we consider that f dash x is equal to 0. So when f dash x equals 0, then you will say that secant square x minus 4 is equal to 0. That means secant square x is equal to 4. Now, secant square x is equal to 4, which is equal to 2 square. So that means you can write sec x as equal to plus or minus 2. So when sec x equals plus or minus 2, that implies that x equals pi by 3, 2 pi by 3, 4 pi by 3, and so on. Because sec of pi by 3 or 2 pi by 3 or 4 pi by 3 for that matter will be equal to 2. I mean, for 2 pi by 3 it will have a minus, but for pi by 3 it will have a plus. Now, the problem here is that since x lies, I mean, instead of saying x lies, you can just write since x belongs to the open interval 0 to pi by 2, then you will need to write x as equal to pi by 3 alone to confirm with the interval given. Now that will give you another 0.5 marks. So now you have x equals pi by 3. So the next thing is that you need to draw a number line. So you can just draw a natural number line. The left side, beneath the arrow, you just write 0. Beneath the right side, you can just write pi by 2. And anywhere on this number line, you can mark a point and then write pi by 3. So the next step here will be to draw a table. So this is x, and this is f dash x equals secant square x minus 4. So now we're going to write the intervals that are given here. So the first interval is 0 to pi by 3, and the next interval is pi by 3 to pi by 2. So 0 less than x less than pi by 3. And what we're going to do is we're going to put in both of these values I mean, we can do it in our head. So secant square x, so when x is 0, secant square 0 will give you 1. So secant square 0 is 1. So 1 minus 4 is minus 3. So that is a negative. When you look at pi by 3, secant square pi by 3, that is 4. So 4 minus 4 is 0. So overall, you have negative value here. So that is a minus. So now we'll take the next interval, pi by 3 less than x less than pi by 2. So pi by 3 less than x less than pi by 2. And pi by 3, so secant square pi by 3 is 4. So 4 minus 4 is 0. Secant square pi by 2, so that is infinity to be exact. So infinity minus 4 is infinity. So you have plus infinity. That means the value will always be positive in the interval pi by 3 to pi by 2. So the first part, that is part A, is to find out which of these is strictly increasing, which of the intervals. So you can write f of x is strictly increasing in the open interval pi by 3 to pi by 2. And you can write f of x is strictly decreasing in the interval 0 to pi by 2. This gives you 1 mark. The other statement will also give you 1 mark. Now, if you are anxious about whether you'll get the right sign here or not, here's a trick to help you out. So you can just mark with pencil. The right hand side is always plus and the left hand side is always minus. So in most of the cases, it helps if you are doing this. So, but in some cases it doesn't work. So even if you do put plus here and then minus here and you get the sign of the intervals, it's better to do the table method because that method is the accepted one. This other method is just to give you, an idea of what the answer is going to be. So you cannot stop your answer out here. You will have to do the table also. The table is very important, even though there are no marks allotted to it, because that table is where the sign gets decided. So that is the last question of this episode. We hope you found this episode interesting and informative. The sample papers for this year are very different because the board, that is Cbse, has made various changes with respect to curriculum as well as examination pattern. So it's very important to look at this year's sample paper. So if you want to look at our other videos, which involve even section 2, that is the radical case study questions, you can always hit the link in the description down below. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audio. So until the next webisode, take care, stay safe, bye-bye for now.